Hi there, and let's have a quick go at this vector question. It goes points A and B have these positions, so that's A and that's B respectively. Point C has a position P1, so that ABC is a straight line. Find the value of P. Right, so we'll do this a couple of ways. I'm going to do it, let's do it the simplest way we can do. So basically, if we can change it into a 2D diagram, so I'm just going to quickly put some axes here. So minus 3, 4, minus 3 and 4 up. There is A, let's say here. B is 1 along, 2 up. B there. Okay, so we've got this line stretching all the way along here. So we got B there and A there. And C is going to be some point on this, where it's P along and 1 up. Okay, so first of all, let's find the gradient of this line. So what we can do is, I'm just going to put minus 3, comma 4, and I'm going to put 1, comma 2. So the gradient of this line is going to be dy over dx, the difference in y's, which is going to be, and plus it's negative 2, so that's going to be, it goes, the difference there, that goes from 2 up to 4, so that's 2, and that's come from 1 all the way, from minus 3 to 1 is going to be 4. Okay, so that's the x and the y there. So we're going to get a gradient, write it here, gradient of A to B is going to be minus 2 over 4. So you've got to come down and go along there. Okay, which is a minus a half. Okay, and then if P is on this line, it's going to satisfy the same equation. So what we can do is, so it's going to be sitting on there. So what we could do is, we could go and work out the equation of this line, or we could get it in relation to one of these points. So again, if I say, let's just say P is somewhere here, sorry, C is somewhere there, and C's coordinates, let's say it's P along the corridor and 1 up, so that should satisfy the same gradient as this one, as long as we get one of these points. So if I go and say P, so if we say P minus, so we can get this point if you want, P minus minus 3, okay, and so that's the x difference, and the y is going to be 1 minus 4. Okay, so that's the difference in y over the difference in x, dy dx, and that's going to satisfy minus 1 over 2. Okay, because it's going to have the same gradient. So what we could do here, 1 minus 3 is minus 3. That's going to become a plus 3. And that's going to equal minus a half. And if I times that up by 2 and times that up by P plus 3, that will give me, I'm going to put it that way, and that times that is going to be minus 6, and that times that is going to equal to, so all that's going to be negative. Or what you could do is get rid of this negative straight away, make them both positive, so we don't need to deal with negatives. Okay, and times that off, so that will give me P plus 3, and take the 3 to the other side, therefore P would equal 3. Okay, so you could do it from that point. I'm going to just use, in case you decided you wanted to use this point, the same thing happens. You do the difference in y, which is, now I'm going to take, it doesn't really matter, I'm going to do 1, take away the 2, over, so that's 1 take away the 2, and P take away the 1. That's going to equal a minus a half. So I should get the same answer here. So that, if we take that away, that's going to give me minus 1 over P minus 1 is equal to minus a half. Get rid of the negatives, times both by negative 1, so that will cancel that out. Times the 2 up, so you get 2, times the P minus 1 up, so that's going to be P minus 1, and again if you bring that minus 1 to the other side, you'll get 3 equals p. Okay, so there's two different ways of doing it there. Well, it's not different ways. All we've done is we use this point, put it into the equation, and to double check it, I put that point, so you get the same thing. Okay, moving on, going on to part B. It goes, and D has a position Q1 and an angle of 90 degrees. ABD, determined value Q. Okay, so we've got a point where it goes A, B to D. If I use a different color here, I'm just going to go down just because it's there. So that doesn't matter which way you do it. Let's say D's here. That's going to give me 90 degrees. It's going to be orthogonal to this line. Okay, so that's 90 degrees perpendicular, and we're going to find D. Okay, so what we do know that this gradient is minus 2. So knowing our perpendicular lines, if I get the gradient of BD, BD is going to be the reciprocal of that negated, so that's going to be the gradient 2. Okay, so that's what it will be on that gradient. And we also know that it goes through this point 1, 2. So let's find the equation then. So we've got y equals, actually I could just do y, take away, so that's x and y take away 2 is going to equal 2, x take away 1. And if we expand that out, we get y minus 2 equals 2x minus 2. Bring that to the other side, plus 2. So y would equal 2x. Okay, so if we know y equals 2x and d sits on that line, we know that d has the position, let's write it as a coordinate, q1. So if we plug that into this equation, don't forget this is x, this is y, so that will be 1 and 2 times q. If we rearrange that, 1 divided by 2 is going to give me q. So the value of q equals a half. Okay, so you could do both of them like straight line equations. Okay, hope that helps.